All right, yesterday we got to about here, and what we have to do now is talk about what your graphing calculator can do and what you have to do by hand. And if you have it in y equals, your graphing calculator, except the TI-83 pluses, they're a little too old and they don't have enough memory, can graph inequalities for you. So there are two different ways that happens. I have the big thick one, so those of you that have the big thick ones, if you pay attention, I'll show you how to do this. What you have to do is go into Apps, which is just to the right of the math key, and then you have to scroll down until you see in equals, which was right there, and you'll press enter, and that'll turn the inequalities on. So I'm just going to put continue on mine so that we can continue to do that. Now, when you go into the y equals screen, you don't see anything different until you go to the left with your arrow and you realize, oh, it's going to let me change that. It doesn't have to be equals now. It can be whatever I want it to be. To get that to happen, you have to hit the green alpha key, and then you have to hit the button that's right below the screen that matches whichever one you want. For instance, I want less than or equal to, so I'm going to hit alpha and zoom, because that's the one that makes that happen. And then I hit the right arrow, and I punch in negative 2x minus 5. And when I hit zoom 6, it's going to not only graph the line, it's going to do the shading for me. Beautiful. Now, the second one here, I would have to do a little bit of work. But before I do that, those of you that have the nice new ones, the thin ones, thinner than this, here's how you get yours to do that. You're going to go into y equals, and you're going to hit the left arrow until you're all the way over to the left, and then hit enter. And that's where it's going to let you choose whether or not you want equals, greater than, less than, all that kind of good stuff. And like I said, TI-83 pluses, I can't do anything for you because it doesn't have enough memory to hold it. Now, if you don't have either one of those, it's because your color calculator needs you to download. It's called an application called Inequalities from the Texas Instruments website. It only takes about 3 minutes. It's super easy to do. And the other thing that you need to know is, if you have to do that, if you do have to download the application, when we take the MCAs and the ACTs, we have to clear your calculator before we start. And because it's a download, it will clear out. There's nothing we can do about it. In the past, I have contacted them and said, is there a way for me to archive it so these students have it on there? Because it's really not fair that the students that had it already on their calculator can use it and these students can't. And they said, no, there's no way to archive it. So hopefully you already have it on and you can figure out how to use that. Now, the next one down here, I have to have solved for y. So I have to do some math. I can't get out of that. And one of the things you have to remember when you're solving inequalities is if you multiply or divide by a negative, you have to flip the sign. So it's going to be y is greater than negative 1/2 x plus 4. So now I can go back, give my calculator what I want it to do, and I'm going to hit alpha and trace so that gives me a greater than, and then parentheses, negative 1 divided by 2, parentheses x plus 4, and graph. And I'm going to look down at my 4 multiple choice answers, and look at it, even dashes the line for you. Isn't that cool? And I'm just going to pick the right one, because that double shading is happening way up there in the upper left-hand corner. That's where that double shading is. Now, I always feel bad because somebody in here will likely forget their graphing calculator on the day of the MCAs. And you're going to come in here and you're going to say, Cedar Home, I forgot my graphing calculator. Can I borrow a graphing calculator? I only have 8 of them. I might run out. We can still do these by hand. I mean, just because you don't have a graphing calculator doesn't mean you just give up. You got to try something. So with this one, we'd say, hey, that's y equals mx plus b. I can graph that. I would go down 5 because my b value is negative 5. And then I would go use my slope of negative 2 to go down 2 and to the right 1. And I do that a couple of times so I have something to aim at and use it backwards. So I have something to aim at in the other direction. And then I'd see, oh, it has an equals bar. That means I need to have it solid. It doesn't go through 0, 0, so let me test and see if I should be shading towards 0, 0. It would say 0 is less than or equal to 0 minus 5. 0 is less than or equal to negative 5. No, it's not. 0 is bigger than negative 5. So I don't shade towards 0, 0. Instead, I shade this way. And then the bottom one, if you don't have a calculator, you might just want to use the thumb method on this one, and this will go pretty fast graphing, because it would be 0, 4, and 8, 0. That would give you your 2 points. Doesn't have an equals bar, so this one's dashed. Doesn't go through 0, 0, so I would test 0, 0 for shading. So 0 plus 0 is greater than 8. 0 is greater than 8. No, it's not. So we don't shade towards 0, 0. We shade the other way. And again, we'd see, hey, there's going to be double shading out in this region up here somewhere. So just because you don't have the graphing calculator to graph inequalities doesn't mean you can't do it. We can still do that by hand. Just have a lot to remember about the pieces to get it there. Alrighty, so let's take a look at example 11. Is there any, I should ask before I go on any further, is there anybody that couldn't get their calculator to do it who should be able to? So you have a TI-84 of one kind or another. Everybody that has a TI-84 is you're able to get the inequalities graphed. That's a big advantage. It really is. So should we do 11 together? Oh, Sarah. Oh, we don't have a packet. That's right. 2 days you were gone. So here's what I'm going to do. I'm going to ask if anybody needs to see number 11. And I don't want you to make a big deal out of it. I'm just going to scan the room. And if anybody gives me a little nod, then we'll do number 11. What you got, McKenna? It should. Yeah, we can graph them by hand. It's just kind of nice to be able to take a brain break, you know. So example 11. Again, if anybody feels like they want to do this one as well, give me a little head nod. Doesn't have to be anything huge. And we can go through another one of those. Okay, so let's do this one. I got a little head nod. I'm going to do this one totally by hand, though. So my question would be, if you had to do this by hand, I know some of you really would prefer to just do y equals mx plus b all the time. Is that what people would do? Is y equals mx plus b? Then let's just do both of them that way. It's a good thing to do anyway, because like I said, we have to remember that if we multiply or divide by a negative, we have to flip the sign. So the top one looks like that, and I need a y by itself. So I'm going to have to add x to both sides. Negative 3y is greater than or equal to x plus 9. And then I have to divide both sides by a negative 3, and that means I have to flip the sign. Austin, you with us back there? Austin Wilkie? Okay. Your focus seemed to be elsewhere there. So negative 1/3 x minus 3. Forgot the x. So we're going to go down 3 because we start with b, and then we're going to go down 1 and to the right 3. Why isn't that letting me extend? There we go. And then we have to figure out if it should be dashed or solid. The top line, should it be dashed or should it be solid? Bless you. Solid. It does have an equals. Let's test 0, 0 and see if it makes sense. 0 minus 0 is greater than or equal to 9. 0 greater than or equal to 9? No. Bless you. So we don't shade towards 0, 0. We have to shade that way. Instead, bottom one is already y equals mx plus b. Yay! So we go up 5. But our slope is negative again, so we have to go down 2 and right 1. Is that one dashed or solid, the bottom one? That one's dashed. It does not have an equals bar. And let's test 0, 0. Is 0 less than 0 plus 5? Yeah, 0 is less than 5. So this one we shade down. And we see the big old double shading region. Bless you. That should be the darkened answer that we get there. So inequalities. They definitely want to know that you know how to graph inequalities. Whether or not you can do it with the calculator or by hand makes no difference to them as long as you can do them. Alrighty, switching gears. Does the following table represent a function? Ooh. What do you think? Do we remember how to tell if something's a function? For every input, there has to be exactly one output. For every input, exactly one output. Does this do that? It does not. It is not a function. That -1 spits out 2 numbers. No. The other thing you could do is you could graph it. Remember, it has to pass the vertical line test if it's a function. So, the other thing to remember, you get as much time as you need to take the MCAs. It is not a time test. So most students finish in between 2 to 4 hours, but I have had some students that have taken like 6 hours because they're just double checking everything they possibly can, and they are using their graphing calculator to go back and check their answers. I had one student that actually took the entire school day. He didn't get a perfect paper, but he did do better than he would have if he'd have like rushed through it. So get as much time as you need to take the MCAs, not the ACTs. Those are timed. All right, example 13. How about this one? Function or not? This one's good? Don't see any repeaters in the X's there? Okay, so this one's good. Now, this we'll be doing tons of in second semester. And that's the last 2 topics for day 2 are things you're going to see more of in second semester. But it's good for you to get a little look at it now and see what they expect you to be able to do. They want you to be able to simplify algebraic division, which is a quotient. So what they're really seeing if you can do is, do you know how to cancel? I mean, that's what they're trying to see, that you know. So I realized 3 is going to go into 3 once and into 6 twice. And as I look at those X's, I have 3 and 4. Well, I could cancel 3 of those out. So I will take all 3 of those, but I'll have 1 of those left down there. For the Y's, I'm going to have 1 still up on the top. For the Z's, I've got a leftover 1 on the bottom. And then you just pull it all together. 1 times 1 times Y times 1 is Y. 2 times X times 1 times Z is 2XZ. Like so. And we're going to learn, well, the rules of exponents that will have that explained a little more thoroughly in next semester. It's actually where we start, chapter 6. So give example 15 a try and check in with your chicken wing elbow partner. See if they have the same thing you do. Keep in mind, when you're simplifying things with algebra, there should only be a variable on the top or on the bottom. There should never be both anymore because you can cancel things out if it's in both the top and the bottom. Take a peek up when you're done. See if we have the same thing. Is that going pretty well? Good. Now, when we get to second semester, we're actually going to find out that instead of all of this canceling, there's another way to figure out what you have. And that's because when you have the same base on the top and the bottom, the x's, the y's, and the z's are the same base, when you need to divide, you subtract. So 5 minus 4 is 1. 7 minus 3 is 4. But 1 minus 5 is a negative 4. And that's the reason it ended up down here, because negative powers make reciprocals. They flip them. But that's something we'll do much more detail in second semester. Now, the other thing that they're going to expect you to know when you get to the MCAs is arithmetic and geometric sequences. Right now, you've never seen these before. So I just want to introduce you to a formula that's not real tough so that you see this is not going to be that big of a deal. It says, write a rule for the geometric sequence, the first term of -4 and the common ratio of -1/2. Now what that means is, we've got this list of numbers, and it's going to start with -4, and to get the next number, what you're going to do is multiply by -1/2. And once you have that one, you'll multiply that by -1/2 to get the next one, and -1/2 again, and again, and again. But it's easier if we know that geometric rules all look like that. A sub n equals A sub 1 times r to the n minus 1 power. So here's what this really says. It says to find any term you want, take the first term times the common ratio, n minus 1 times. Well, they told me what the first term was. That was a -4. And they told me what the common ratio was. That was a -1/2. There it is. So we'd look through the multiple choice answers, because sometimes they don't use A, which is silly, because anybody that knows math, we always use lowercase a's for geometric and arithmetic. But they don't, because they want to mess with your head a little bit. So they might do T sub n or something goofy like that. But that's what they look like. Now, if somebody says, find me the 15th term, well, all I do is put a little 15 here and a little 15 there and do the math on my calculator to get the 15th term. That's all I have to do. That's why there's another problem down here, because I want to do one where we actually do the follow-up to this. So it says, what is the 8th term? So we're going to have to write the rules so we can find it. And it has a first term of -2/3 and a common ratio of 3. So A sub n equals A sub 1 times r to the n minus 1 would be -2/3 times 3 to the n minus 1. So we write the rule, and then we say, oh, they wanted the 8th one. So I have to put a little 8 in there. A sub 8 equals -2/3 times 3 to the 8 minus 1. And this stands for the 8th term, which is exactly what we're trying to find. So we would follow the order of operations and punch this in and say, well, I need 3 to the 7th. I can do that little math in my noggin there. And then I have to take that times, parentheses, -2 divided by 3. There it is, -1,458. So once we have the formula, things go easy from there. Second hour, somebody's hand went up right away and they said, are they going to give us that formula? No, they won't. But it will be, these formulas will be the last formulas that we study before you take the MCA. So they'll be right up here anyway. You know, you'll have them in your noggin. And those should be some that are pretty easy for you in basic when we get to that point. Alrighty, now D3, which we won't get through, but we'll do as much as we can. Starts by talking about just, can you graph your answers? They want to make sure that you know how to find your answers on the number line. Shifting parabolas. We've done that a lot. I mean, you did it in exponential, you've done it in Algebra 2, so we should be able to tell them, hey, it's translated this way and that way. Max and min, yeah, we even have Blinky for that now. We don't have to do it by hand if we don't want to. Perimeter of an arc, that was geometry. Lots of people tend to forget that. Volume of a box, again geometry. Perimeter of a fence, again geometry. And then every year they stick a voting question on the math test. And we kind of turned that over to the social studies department and said, can you cover the different voting methods so students would know what they're doing mathematically? But we'll at least talk about majority vote. Now, we won't probably get through all of these today, but that's okay. We'll do as many of them as we can. It's always a good review. So this says we're supposed to graph the answer to 3x plus 5 equals 7. Well, to do that, we would need to know what the answer is. That's some basic algebra, isn't it? Let's subtract 5. And divide by 3. Well, and we'd make ourselves a little number line. And we would say to ourselves, self, I need to graph 2/3. Well, it's between 0 and 1, but it's 2/3 of the way, so it's closer to 1 than it is to 0. And it's going to be multiple choice anyway. So, you look down. Just be careful because some people accidentally graph negatives and stuff like that. It's just one of those little things. Our brain gets all goofed up because we're taking an important test. And we mess ourselves up. All right, having done that one, does anybody need to do example 2? Again, you can just give me a little head nod as I go around. See if anybody needs example 2. All right, looks like we're good to go there. But we had best do example 3 because this is an inequality. This is not an equals. So with this one, we still have to solve it because it says graph the answer. So we're going to have to subtract 5. Negative x is greater than or equal to 2. And the next step is a big one. Because what do we have to do? Got to flip the sign. Divide by -1, bless you. And flip the sign. Alrighty, little bitty number line, -3, -2, -1, 0. And here's where we pull stuff way, way down deep out of the memory banks. Open or close dot at -2. Closed, it has an equals bar, that's closed. And if all of our answers have to be less than or equal to -2, should we shade left or should we shade right? Yeah, left. That's where the numbers are smaller than -2 because it says x is less than or equal to -2. So the key to those is remembering, hey, if I multiply or divide by a negative, I have to flip the sign. I have to. So how about example 4? Let me take a peek around the room. Anybody feel the need for example 4? Go ahead, nod. Only you and I have to know who you are. Okay. Got it. Let's move on. Oh, example 5. They do this all the time. They put things in the wrong order to try to mess with our heads. So you have to be careful when you're reading. Describe how the graph of y equals x squared plus 2x minus 7 can be obtained from the graph of y equals x squared plus 2x minus 1. Well, that means even though they wrote this one second, this is the first one. So they started with this, and they got this. So what I usually do is write it below it and then scratch that out so I can remember this was the first one because they said that's what they obtained it from. That's what they started with. Well, they look pretty similar. There's only one difference, right? A -1 became a -7. So what do you do to a -1 to get a -7? Subtract 6. What does a -6 in the back of our formulas do to the graph? Down 6. Translate. Down 6 units. So that's really what they wanted to know. You know, what change is happening here if we go from -1 to -7? Let's give another one of those a try, just so we don't forget that they try to pull the trick of reversing stuff on us. Describe how the graph of y equals 2x squared minus 3x plus 1 can be obtained from the graph of, so that means they started with this, y equals 2x squared minus 3x minus 4. So how do we go from -4 to 1? Add 5. What does a plus 5 in the back mean to us? You got it. What I need you to notice about this is, do you agree this is a pretty basic question? Do you also agree that they're trying to mess with our heads by putting them in the wrong order? Absolutely. And you know they're going to put the mistake answer down because they're mean that way. They just do. That's what test writers do. Alrighty. Now, oh, this is a good one too, but I'll bet you could do this on your own. Does the graph of y equals x squared minus 4x plus 2, does that have a maximum or a minimum? And where is it? Let's say we didn't want to use the calculator on this. We're like, I got this. Does this open up or down? It opens up. It's an x squared, and it's positive. So does that have a max or a min? It has a minimum. And we could certainly use Blinky to do it, but like I said, let's just say you forgot your calculator or whatever. If that's the case, then you have to remember the little formula to find the x-coordinate of the vertex on a quadratic. Does anybody remember the little formula that we use? It's been a couple of chapters. X equals -b over 2a. That'll get us the x-coordinate of the vertex. So it would be the negative of -4, which is positive 4. And then over 2 times 1, well, that's 4 divided by 2. So the x-coordinate is 2. And then to get the y, you just plop the 2 into the formula up there. So 2 squared minus 4 times 2 plus 2. Well, that's 4 minus 8, which is -4, and -4 plus 2 is -2. 2, -2. However, this is a problem that I hope you go brain dead on. You take a little brain break, and you just grab your graphing calculator. I don't like it when the inequalities are on. You can change that back to equals or turn the inequalities off. You go back into the apps, pick it again, and then choose to turn it off. But we need x squared minus 4x plus 2. Zoom 6. And of course it opens up. Second trace, number 3, the minimum, and let Blinky find left side enter, right side enter, enter through guess. Ta-da! Super close to 2, -2, because Blinky had to do some calculus, so Blinky's a little bit off. It's 2, -2. So absolutely, go brain dead on those problems. You know, say, oh, my calculator will do this whole thing. Let me just have the calculator do that. Save your brain power for the toughies. So, in example 8, we're supposed to find the max or the min. Again, I'm going to look around. If you want it, just nod your head slightly, and I will know. Okay, let's do another one. So this one, is this going to open up or down? And we would be finding the max. But again, my hope is you go brain dead, and you come in here, and you tell your calculator you want -2x squared plus 2x minus 5. Zoom 6. You see you were right, and you say, oh, I need the maximum. So second trace, number 4. And I need to be on the left side of the hill and press enter, right side of the hill and press enter, and enter through guess. It's really close to 0.5, -4.5. Or 1/2 and -4/5 as an improper fraction. Let me remind you of how you do that. So that would be 9/2, -9/2. If you saw fraction answers down there for everything. And again, you could do that by hand with the little x equals -b over 2a and plug that back in. You will get 1/2 and -4.5. Alrighty. Ooh, what time are we out of here on? It is still 49 on Wednesdays, isn't it? Okay. So example 9. Ooh, memory banks. arc length from geometry. Nobody went, yes, I got this. Okay, so find the length of the arc in this picture. That would be this arc right there. So here's what we have to do. We have to realize we're not using the whole circle because we just want this little piece right here. But that little piece is a part of the circumference. So we have to remember the circumference formula, which, if we don't remember, happens to be one of the formulas they do give you on the formula sheet. It's either 2 pi r or pi times diameter. So I need the circumference, which would be 2 pi r, but I can't use the whole circle. All right, let's see. So what part of the circle am I using? I'm using 70 degrees out of the whole circle. How many degrees are in a whole circle? We just found the part we need. That is the fraction of it that we need right there. And then they'd probably give the answer as a decimal. So we would want to punch it in. All right, calculator, I need 70 divided by 360, parentheses, times 2, times pi, times 8. Blammo. Whoops. 70 divided by 360 times 2 times pi times 4. Oh, I did pi d in my noggin, and then I wrote down that. There we go. 4.89 inches. And the reason I did that is because I wanted to check the formula sheet. Yeah, they give you circumference equals pi d. That's not, typically you learn 2 pi r in geometry, but pi d works as well. Well, we didn't get through them all, but we got through a lot of them. So I don't think we'll have time to come back and finish up the rest of this, but there's a lot of time yet before you take the MCAs. So we can still get that in at some point. Finish up the rest of this wonderful packet here, the rest of those multiple choice questions. So 17 through 24.